Alzheimer dementia, also known as Alzheimer disease, is a common progressive neurodegenerative disease. Chances are you probably know or have heard of someone with the disease, as Alzheimer is the most common form of dementia affecting millions of people around the world, which makes it very important for any healthcare practitioner to know. In this visual mnemonic video, we'll cover everything you need to know about Alzheimer dementia so that you'll be ready to crush it on test day. We've landed in the lab of a reclusive alchemist who concocts all sorts of magical potions and serums. This alchemist here is our memory anchor for Alzheimer dementia. Get it? Alchemist for Alzheimer? Now that we've anchored ourselves to the scene, let's explore further to learn more about the pathophysiology of the disease. Let's take a closer look at the alchemist's lab. Like many zany scientists, this guy has hidden his life's work away inside of an ancient temple. You can tell the location by the crumbling stone wall with the word temple etched into it. Anyways, this temple is our symbol for the temporal lobe, because temple kind of sounds like the temporal lobe, right? What's more, the crumbling or degeneration of these temple walls can help you remember that Alzheimer dementia is associated with degeneration of the temporal lobe. In particular, Alzheimer dementia affects the medial temporal lobe, which is primarily responsible for memory and emotions. This region includes the amygdala, entorhinal cortex, and hippocampus, which we'll discuss in our next symbol. A long time ago, this temple had once been a place to worship the mythological underwater seahorse, the hippocampus. That's why there is an ancient seahorse statue here. The seahorse statue here is our symbol for the hippocampus, because hippocampus is literally the Greek word for seahorse. And the hippocampus literally looks like a seahorse-shaped brain structure on gross anatomy. Notice how this seahorse statue is crumbling down and degenerating like the rest of the temple. Pulling everything together, let this crumbling seahorse remind you that Alzheimer dementia is associated with degeneration of the hippocampus. As we mentioned earlier, the hippocampus is a part of the medial temporal lobe, but it's one of the more important structures to know about for this disease. The degeneration of the hippocampus causes memory impairments, which lead to the characteristic signs and symptoms of the disease. This ancient temple can get a bit drafty. It's a good thing our alchemist is wearing a warm down jacket. This down jacket also happens to be our recurring symbol for Down syndrome. Down syndrome, or trisomy 21, is often associated with early onset Alzheimer dementia, which begins in people under the age of 65. This is due to the presence of an extra copy of the amyloid beta precursor protein on the extra copy of chromosome 21. In Alzheimer dementia, the amyloid precursor proteins, or APP for short, undergoes abnormal breakdown to form harmful beta amyloid plaques. We'll go over these plaques and why they might cause Alzheimer dementia later on. But for now, just use this down jacket to remember that Down syndrome is associated with early onset Alzheimer disease. Got that? Next, check out this bottle of cola shattered on the floor. Something must have startled the alchemist and made him accidentally drop his drink. You might remember from previous videos that dropped cola is our recurring symbol for decreased acetylcholine. Get it? Dropped cola for decreased acetylcholine? Acetylcholine is a crucial neurotransmitter that plays key roles in memory and cognition. In Alzheimer dementia, there is an overall decrease in acetylcholine production from the nucleus basalis of Meinhardt, the place where a lot of the acetylcholine in the brain is normally produced. Patients with Alzheimer dementia are thought to have decreased choline acetyltransferase activity in this area, which decreases the production of acetylcholine. Ultimately, the insufficient acetylcholine levels can cause the cognitive decline that is characteristic of Alzheimer dementia. Now that we've discussed the main properties of Alzheimer dementia, let's move on to its clinical presentation in patients. Look in the distance where an explorer is trying to find the alchemist's secret lab. This must have been the distraction that caused the alchemist to drop his cola. Anyways, it looks like the explorer is using the alchemist's old memoir to trace back the location of the lab. Unfortunately, the memoir's text has faded gradually over time, making it really hard to read the directions. This gradually fading memoir should help you remember that patients with Alzheimer dementia present with gradual memory decline. Get it? A gradually fading memoir for gradually fading memories? Gradual memory decline is actually the most common symptom of Alzheimer's dementia in elderly patients. Again, the memory decline here is characterized by an insidious onset, which is just a fancy way of saying that it declines gradually and slowly over time. This is in stark contrast to vascular dementia, which involves quick, stepwise cognitive decline. The alchemist didn't want to reveal all of his discoveries to the nosy explorer, so he quickly tore up his planner filled with all of his plans for future experiments. Let this torn planner remind you that patients with Alzheimer's dementia also present with impaired planning and organization. This executive dysfunction is likely due to the degeneration of cortical neurons. Luckily for the alchemist, his secret lab is hidden behind a long, winding labyrinth. The explorer has to find his way through the complex maze in order to reach the lab, but the memoir instructions are so severely faded that the explorer is completely lost. Let this explorer, who is lost in the maze, help you remember that patients with Alzheimer's dementia often experience visuospatial impairment. This often causes them to get lost in familiar environments, like in their neighborhood and even inside their own homes. Now that we've covered the three main symptoms of Alzheimer's disease, let's move on to its diagnosis. The first method we'll discuss is by looking at sections of the brain under the microscope, which unfortunately usually only happens post-mortem. One of the alchemist's most prized possessions is an ancient amulet with magical powers. If you take a closer look, you'll see that the amulet is in the shape of a bat. This bat amulet is our symbol for beta amyloid plaques. Get it? A bat amulet for beta amyloid? Brain biopsies of affected patients often reveal accumulation of beta amyloid, which forms plaques inside the brain. Also known as neuritic plaques, this beta amyloid is actually formed from extracellular deposits of fragmented amyloid precursor protein, or APP. These plaques cause damage to nerve cells, leading to brain degeneration. Importantly, one stain that pathologists can use to see this amyloid is known as the Congo red stain. Under the microscope, this amyloid gives off an apple-green birefringence under polarized light, which can be a clue that you're dealing with amyloid. Next, the alchemist is quickly gathering his supplies in order to make a hasty escape. He's using a tow truck to haul all of his gear and alchemy ingredients. This tow truck is our symbol for tow proteins. Get it? Tow truck for tow proteins? What's more, it looks like the alchemist has acquired a bunch of parking tickets during his excursions into civilization to gather ingredients. These many parking tickets are our symbol for hyperphosphorylation. You know, because the letter P is the symbol for phosphate, and there are lots of them here. Pulling these together, the many parking tickets on the tow truck is our recurring symbol for hyperphosphorylated tow protein. Tow proteins are normally associated with microtubules and help to stabilize them in brain cells. However, in the case of Alzheimer's dementia, these proteins become hyperphosphorylated and dysfunctional. But you might be wondering just why these hyperphosphorylated tow proteins are problematic. We'll answer that in our next symbol. In his panic to escape, the alchemist got the cable between the tow truck and its carriage all tangled up. Let's hope he can quickly detangle it before the explorer arrives. This tangled tow cable should help you remember neurofibrillary tangles. Get it? The tangled cable for neurofibrillary tangles? You see, hyperphosphorylated tow proteins tend to dissociate from their microtubules and instead aggregate together into long tangles of tow proteins. These are formally known as neurofibrillary tangles. These tangles can then cause severe disruption to cell function, ultimately resulting in brain cell death. Along with beta amyloid plaques, neurofibrillary tangles are commonly found through brain sections of affected patients. In fact, neurofibrillary tangles are so prevalent in Alzheimer's dementia that they are actually one of the primary markers of the disease. Now, looking at a section of the brain under the microscope is possible after death, but as you can imagine, you can't really justify taking a section of the brain out of a living patient. This is why diagnosis can also be supported by clinical reasoning and brain imaging techniques. Let's talk about these imaging findings next. The alchemist has some pretty odd materials he uses in his experiments. Is that a jar with a brain? That's right, since every zany alchemist obviously stores brains in jars. This brain must have been here for a while since it's all shriveled up and shrunken. This shrunken brain in a jar is our symbol for diffuse brain atrophy. Get it? Because atrophied brains look shrunken on imaging. What's more, the diffuse brain atrophy seen in Alzheimer dementia leaves more room inside the skull, which is in turn filled by increased cerebrospinal fluids. Just like how this jar here is filled with a bunch of fluid surrounding the shrunken brain, right? Brain scans of patients' brains often show diffuse brain atrophy, which describes widespread loss of brain cells. Consequently, the brain loses a significant amount of volume, which is replaced by cerebrospinal fluid in the skull. These changes in volume can be detected through brain MRIs and CT scans. Before we end, let's quickly cover some treatments for Alzheimer dementia. We won't symbolize these here since we actually have dedicated scenes on each of these drugs in our pharma collection. You should check them out sometime. Firstly, Alzheimer disease is often treated with cholinesterase inhibitors like donepezil, rivastigmine, and galantamine. For a quick review, these cholinesterase inhibitors work by increasing acetylcholine levels in the brain. This helps improve memory and cognition. Next, Alzheimer dementia can also be treated with memantine, a drug that works by inhibiting NMDA receptors in neurons of the brain. This is thought to reduce the excitotoxicity of neurons, thereby slowing the progression of neuronal death and dementia. Alright, that's all for Alzheimer's dementia. Let's recap what we've learned. Alzheimer dementia, also known as Alzheimer disease, is a neurodegenerative disease that primarily affects the medial temporal lobe, and in particular, the hippocampus. Early onset Alzheimer dementia is associated with trisomy 21, or Down syndrome. Neurotransmitter changes seen in Alzheimer patients include decreased acetylcholine levels, which may contribute to cognitive impairments. Patients with Alzheimer dementia generally present with a slow, gradual memory decline, along with impaired planning and visuospatial awareness, which can cause them to get lost in familiar environments. Alzheimer dementia can be definitively diagnosed through histopathology of brain sections under the microscope, which may reveal beta amyloid plaques or deposits of hyperphosphorylated tau proteins known as neurofibrillary tangles. This is not ideal for diagnosing the disease in living patients, where clinical inference is preferred and brain imaging can be used to supplement a diagnosis. These brain scans often reveal diffuse brain atrophy, with enlargement of the surrounding fluid spaces to occupy the space left by the shrunken brain. Finally, Alzheimer dementia can be treated with cholinesterase inhibitors like donepezil, rivastigmine, and galantamine, as well as NMDA receptor antagonists like memantine. And now we're actually done with Alzheimer dementia. Let's help this alchemist untie that tangled rope so we can escape before that explorer finds us too. Maybe he'll set us up with a free potion to easily memorize everything you need to know for the boards. Or maybe he'll just give us a free Pixarize account. Who knows? See you in the next one.